In this video, we are going to solve problem 4-111 that is taken from chapter number 4, Pure Bending, and book name is Mechanics of Material by Beer and Johnston, 6th edition. So statement is an offset H must be introduced into a solid circular rod of diameter D, knowing that the maximum stress after the offset is introduced must not exceed 5 times the stress in the rod when it is straight. Determine the largest offset that can be used. So you can see this is the rod that is exerted by a tensile load P dash, and the diameter is D. Initially it is straight, and it can be seen that an offset H must be introduced. Clear? In this straight rod, which is initial and that is causing maximum stress after the offset is introduced, must not exceed 5 times the stress in rod when it is straight. So you have to determine this largest offset that can be used. So let's start with the solution. What will be the first step? At first we will find the stress in this straight rod, and when you find it, you will have to cut it and draw the free body diagram. So you can see over here that I have cut it. So when you cut it, so you will definitely having same opposite force in this direction, that will be equal to P. So I can write it. Now you can see this is the case for centric loading. So centric loading means that this load passing through the center of this rod, and you can see from the diagram, so we can write that centric stress is equal to P divided by A. Let this is your equation number 1. Now you can see when this is given an offset of H, clear, and when you cut it over here, for this I will choose this blue color. So if I again cut it over here and draw the free body diagram, so definitely at this end you will be having a centric load which will be equal to P, and now you can see you will be having a moment as well. Why? Because this is not this is no more centric. One load is applying over here and other load is applying over here, and in between these two there is a eccentricity or offset distance, and due to this it will create a couple like this, and this moment will be equal to the product of this force into distance between them. And let me show you over here what will be that. So you can see that this load offset distance is this from top till this, clear, this is H, and you can see this load is applied exactly to this. So similarly the same force will have the same, and you can see it is equal to half. So this is H, and this P multiplied by H will give you this moment. So I can write it over here that for eccentric loading, this moment will be equal to P times H. Let me show you by using another color. You can see this is the load distance. So here this distance will be also H. Why? Because from top till this distance is till the mid, so this distance will be also H. So this force and perpendicular distance between them is H, is producing couple. So that's why we have moment like M is equal to PH. Now here you can see you have normal load and moment. So what will be the stress? That will be eccentric stress, and that eccentric stress will be equal to sigma E, and that will be equal to the stress due to normal loading, or P by A, plus the stress due to movement, which is equal to M into C divided by I. And what is C? So C is equal to D divided by 2, which is equal to radius, because we have been given the diameter of this rod is D, so C will be radius, and that will be equal to D divided by 2. And also we have been given that eccentric stress should not exceed 5 times the stress of centric. That is the given condition. So we call this as equation number 2 and this equation number 3. Now what we will do is that you will put the value of equation 1 and 2 in equation number 3. So this is equation number 3. Let me write it again. Sigma E is equal to 5 times centric loading, and we know that sigma E is equal to P divided by A plus what is M? M is equal to P times H into C divided by I, and that will be equal to 5 times P divided by A. Now if you rearrange, so P into H divided by C, P into HC divided by I is equal to 5 P over A minus P over A, and that will give you 4P by A. Okay, so again I will write P into H into C divided by I will be equal to 4P divided by A. So P will cancel with this P, and what we need is that we need this H. So this H will be equal to 4 times I is the second moment of inertia. So 4 times I divided by A multiplied by C. Divided by C. Now what will be the area? So if diameter is given, so area is equal to pi by 4 d square. And what is the moment of inertia? So for diameter d, it is equal to pi by 64 d power 4. This is the formula for second moment of inertia of solid circular shaft. Or if you use radius, so then it will be equal to pi by 4 c power 4. We will use this because all the values are given in diameter. Okay, and you can see as we are using diameter, so C is also here, so we can write C as equal to D divided by 2. Now put all the values, so H is equal to 4 times pi by 64 multiply by D power 4 divided by area is pi by 4 D square multiply by C, and C is again D divided by 2. Okay, so that will give you 4 pi over 64 D power 4 divided by pi D cube over 8. Okay, now if I further simplify it, so this 4 will cut with this. No. It will not cut with this because, okay, so this 8 will cut this with this. So 8, 64. So we will get 4 pi over 8 d power 4 divided by pi d cube. Okay, pi will cancel with this, and 4 1s are 4, 4 2s are 8. So 1 over 2 d power 4 divided by d cube. And when you solve it, you will get 1 over 2 times d. So it means that maximum offset will be equal to 1 over 2 times diameter of the rod. This is the offset that we can give to this rod in order to get the condition that where eccentric stress should not exceed than 5 times the centric load. And that was all about this problem 4.111. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.